Ever wondered why your AI assistant sometimes gives you an answer that's almost right, but misses the big picture? Like when it talks about Messi's goal, but forgets to mention how it's compared to Maradona's legendary play. That's the problem Q-Iter is solving, and it's changing how AI finds answers forever. Let's start with the basics. Traditional systems, like search engines or chatbots, often treat information like isolated puzzle pieces. They might find Messi scored a goal, but miss the deeper context of how that goal stacks up against history. It's like searching for a recipe by looking for flour and sugar and oven, but never realizing they're all part of a single, connected process. Q-Iter fixes this by building a smart network of connections, a multi-partite graph. Think of it as a map where every road, landmark, and shortcut is labeled. This graph links three things. 1. Text chunks the raw info, like a paragraph about a soccer game. 2. Knowledge units core ideas, like Messi's goal compared to Maradona's. 3. Entities, specific people, places, or things, like Messi or European Cup. This structure is like a crossword puzzle, where each clue connects to the next. But here's the genius. Q-Iter doesn't just store data, it thinks about it. It uses a hybrid extraction strategy to save time and money. For most tasks, it uses lightweight tools to scan text. But when it hits a tricky part, like decoding a nuanced comparison between Messi and Maradona, it calls in the big guns, powerful AI models. This cuts costs by 72% without sacrificing accuracy. Now let's talk about Q-Iter, the star of the show. Imagine you're searching a library, not just by title, but by following a trail of clues. Q-Iter starts by anchoring your question to the graph. If you ask, how did Messi's goal compare to Maradona's? It first identifies Messi and Maradona as key entities. Then it uses semantic search to find related knowledge units, like goal of the century or legendary play. It keeps expanding, hopping between facts and entities, while a lightweight scorer ensures everything stays relevant. It's like having a detective that refines its search with every clue. But how do we know this works? The experiments tell the story. Q-Iter outperformed existing systems by up to 99% in accuracy and 113% in F1 score, metrics that measure how well it answers correctly and comprehensively. Even when they dialed back the AI usage to save costs, Q-Iter still crushed the competition. For example, with a cost-saving setting, it improved accuracy by 20% while using 83% fewer resources. It's like getting a 5-star meal for a budget price. The secret sauce? A hybrid approach that balances AI power with smart shortcuts. Instead of randomly picking data chunks, Q-Iter uses advanced methods like BLEU scores and cosine similarity to find the most relevant pieces. In tests, this approach outperformed random selection by over 3% in accuracy. And here's a fun twist. Even when the AI was turned off completely, Q-Iter still matched or beat systems like SIRAG, proving that its graph structure alone is a game changer. So what does this mean for you? Imagine a world where AI doesn't just guess answers, but navigates a web of interconnected knowledge. But here's the kicker. Even the most advanced systems like Q-Iter rely on fine-tuned parameters to operate efficiently. Let's dive into how researchers tweak these invisible knobs to make AI smarter, faster, and more precise. Ever wondered how AI systems like ChatGPT or Gemini fine-tune their answers to be smarter, faster, and more accurate? It's not just about raw power, it's about precision. Today, we're peeling back the curtain on how researchers adjust the inner workings of AI to make it better at answering questions. Let's talk about parameters, the secret knobs and dials that control how AI thinks. Take top K, for example. This parameter determines how many results the AI considers. Imagine searching for a recipe. Too few and you miss key details. Too many and the AI gets confused. Researchers found that 3 was the sweet spot, a balance between depth and efficiency. Next up, beam size M. Think of this as the AI's search width. If you're navigating a maze, a wide beam like M equals 10 might explore every path, but that's slow and messy. The team found M equals 5 struck the perfect balance. It's like having a flashlight that illuminates just enough of the maze to find the exit without getting lost in dead ends. Now search depth D, how many steps the AI takes to dig for answers. A shallow search D equals 1 is quick but might miss the big picture. A deep search D equals 10 could uncover gold or get stuck in a rabbit hole. The sweet spot? D equals 3. It's enough to connect the dots without overcomplicating things. For example, if you ask, why did the Roman Empire fall? The AI checks 3 layers of clues: economic issues, military struggles, and political chaos, without diving into unrelated details like ancient fashion trends. Finally, there's token constraint, alpha, which controls how much text the AI processes at once. Picture this, you're reading a book, but you can only take in 1 sentence at a time. That's alpha equals 0, 1. But if you let the AI read the whole chapter, it might get overwhelmed by side stories. The researchers found that alpha equals 1, letting the AI process full passages, gave the best results. It's like giving the AI a highlighter to focus on the most important parts of a text, rather than getting lost in the margins. So what's the takeaway? These parameters aren't just numbers, they're the keys to unlocking AI's potential. By testing values like top K equals 3, M equals 5, D equals 3, and alpha equals 1, researchers are making AI faster, more accurate, and less prone to guesswork. And here's the kicker. These tweaks aren't just for fancy labs. They're making their way into tools we use every day, from chatbots to smart assistants. Next time you ask an AI a question, remember, behind the scenes, it's juggling these tiny adjustments to give you the best answer possible. Stay curious and keep exploring the frontier of AI.